Okay, in this lesson we'll address the question, how are cortical memory traces strengthened? We left the condition of the brain in a state where we had weak cortical memory traces due to lower levels of plasticity among cortical neurons, but a strong hippocampal memory trace because hippocampal neurons show high plasticity. And we said that during retrieval then we're going to need this strong hippocampal memory trace to help reactivate the cortical memory traces. But we've also learned that we don't need a hippocampus to retrieve cortical memory traces if those memory traces are strong. And the condition of H.M. and Clive showed this. They could retrieve memories from long before the damage to their hippocampi. So the question then, of course, is how is it that the brain is going to strengthen these cortical memory traces so that we don't need the hippocampus for retrieval? In the last couple of decades, scientists have made a really interesting discovery. A lot of this strengthening of cortical memory traces occurs during sleep. So we say new memories are consolidated during sleep. So this term consolidation refers to the strengthening of the cortical memory traces over time as we sleep. So it turns out when we go to sleep, the hippocampal memory traces are reactivated and they signal the linked cortical memory traces to strengthen their synapses. There's direct evidence for this kind of process happening. So this research has been done in animals. Scientists can record hippocampal neurons as they learn, and when they go to sleep, those same hippocampal neurons are turned on again, and they are communicating with the cortex. And the idea is that that communication is strengthening the cortical memory traces. So by firing up the recently formed memory traces, the brain is processing recently learned information. And using our analogy here, the hippocampus is applying more ink, helping those cortical memory traces get stronger. Notice then that during sleep, the information flow is from the hippocampus to the cortex, which is the reverse of what's happening during the encoding and storage stage. During encoding and storage, the flow of information was from the cortex down into the hippocampus. But during sleep, the hippocampal memory traces are turned on and are used to strengthen the cortical memory traces. Notice the picture during sleep is similar to retrieval, where again the hippocampal memory traces are going to be needed to reactivate cortical memory traces. So we can use our metaphor then that the hippocampus is playing the role of a teacher here. The hippocampus made memory traces that sort of captures the pattern of activity in the cortex, and during sleep the hippocampus is going to teach the cortical memory traces to get stronger. Another analogy would be the hippocampus is writing data to the hard drive. The cerebral cortex would be the hard drive, the long-term memory storage system. In addition, what's happening during consolidation is that the strengthened cortical memory traces are going to be linked together. There are other areas of the brain, sometimes referred to as association areas of the brain, whose job it is to link these separated memory traces to form one sort of coherent memory trace for the entire event. After all, each of these memory traces in the separated areas of the brain here, they happened at the same time. It was one learning event, and so the brain can link those memory traces together. This will allow me to, when I see a picture of the solar eclipse, then I can sort of reactivate what the sand felt like and the sounds of the crowd. And so all the separated memory traces become linked together. Now, scientists have measured the activity of hippocampal neurons during sleep, and they found that these neurons accelerate their firing by a factor of 20. So a single learning event can be replayed hundreds of times during sleep. Sometimes this is referred to as hippocampal replay. And this then creates ideal conditions for synapse growth and memory trace connection. Remember, we need multiple activations to get those cortical neurons to really grow stronger and stronger synapses. Well, that's exactly what's happening during sleep. Using our metaphor, the hippocampal replay is applying lots of ink up here in the cortex, strengthening those cortical memory traces. And as a result then, of successful consolidation, and this may take several nights of consolidation for the same memory traces, we're going to have strong cortical memory traces that we don't need a hippocampus to retrieve. Other frontal cortex retrieval systems can activate the entire memory trace. But why are some memories strong with only one learning episode? After all, didn't we say that after one learning episode we have weak cortical memory traces that we may fail to reactivate and so fail to retrieve, even if we have a strong hippocampal memory trace? Well, here the idea is that certain emotions enhance the strength of hippocampal memory traces. So any kind of event where the emotions are turned on, and the solar eclipse was certainly one such event, any event where emotions are turned on, that helps the brain store strong hippocampal memory traces, and indeed also stronger cortical memory traces relative to a situation with lower levels of emotion. So the result then would be that emotional events undergo strong consolidation. No repetition of the event is necessary for strong cortical memory traces to emerge. Now, much of school learning is typically less emotional than witnessing a solar eclipse, hence the need for spaced and repeated study. So the idea is that we're going to need to study the same material multiple times to give our brain the chance to really strengthen those cortical memory traces. Here we see sort of a diagram capturing what's happening over time as we study 1, 2, 3 times, separated perhaps on each successive day. Well, each time we study, the first day, then the second day, then the third day, we're giving our brain the chance to go through this consolidation process. And each time the brain goes through the memory consolidation process during sleep, we're strengthening those cortical memory traces. So these would be the same files up there in the cerebral cortex. It's the same information, as it were, that we're studying. So remember, we want to have multiple study sessions because the cortical neurons, they show low plasticity. So we have to study repeatedly to give the brain a chance to strengthen those cortical synapses to make strong cortical memory traces. So we've got to study multiple times, especially when the information is less emotional than, say, a solar eclipse. Now, there's reason to believe that when we study on successive days, we're actually writing separate hippocampal files, and we'll see why scientists think that in a later lesson. But the general point, though, is that by repeating your study sessions, you are giving your brain the chance to strengthen and strengthen and strengthen those cortical memory traces so that you'll have easy access to them in the future. Using our metaphor again, by spacing out study sessions, we're allowing the printer, the hippocampus, to apply more ink to those cortical memory traces. By definition, then, cramming involves a single learning episode and therefore deprives your brain of the opportunity to make stronger memory traces in the cortex. So if you only do one study session right before the quiz or the test, you're going to be left with relatively weak cortical memory traces. Much weaker than you could have had if you used multiple study sessions spaced out in time. You might do okay on the quiz, but you are likely to forget the information quickly.